All right, welcome back. We are on class 2 talking about module 3. We're going to do a little bit deeper dive into using for and while loops. We've already talked about them when we talked about loops up here, and I showed you some examples. And I did that on purpose. My methodology here is to give you a little exposure, and then now we're going to go into a little bit more deep dive on looking at these two types of loops in more depth. The idea here with iterating through loops and for loops and while loops is I want to explain what the concept of a loop is. The loop is allowing us to take some block of code. Remember, everything that's indented to the same indentation level is considered a block of code. We're going to run all of those lines of code repetitively, so over and over again, until some certain condition has been met. So if I'm doing some kind of network listening, socket listening, I may sit there in a loop and every second check to see if any network traffic has happened. And if there is traffic, then I will start to handle that traffic and I'll break out of my loop. So my listening loop is just kind of sitting there in the background, every so often just checking to see if any information has been received across the network. So that's a good example of where we would use loops in the background. It's really important to understand the concept of looping in the sense of automation and repetitive tasks are really easy to do with loops. So I master it one time, figured out all the logic that I want to set up, and then I just redo that same thing on the next system. So it gives us the ability to easily take a task and break it down and just do it over and over and over again. All right, there's two types of loops in Python. We've seen them both. The while loop is really good at doing things some unknown number of times. Now I can also do it a fixed number of times, but where its strength comes in is doing it until some condition is met. Till the user types the word exit, till the network has received the traffic, until our shopping cart is full. Some condition happens that helps us break out of a while loop. Whereas a for loop is perfect for going over a defined number of items. Say I have a list of items. I know ahead of time it's got 100 items in it. That's perfect. A for loop can go over each item in that list. So we have the two different loops because they have two different purposes, and they're both efficient at doing their specific purpose. Now, I could do a for loop and make it mimic a while loop, but it's going to take me some extra code and it's not going to be as elegant and clean. And I can also do the same thing with a while loop, make it function very much like a for loop. Again, not going to be as clean and elegant, but I can do those things. So these are just two tools in our belt for looping to make our programs be able to iterate over and do things repetitively. Then what I want to do is I want to give you 3 examples. And I'm purposely doing this because this is going to be a lead-in to our next class, right? So when we talk about different data structures, lists, tuples, and dictionaries, I want to give you a little bit of exposure to those. So I might do a list example, and I'm going to do a string example just to show you strings, and then a dictionary example as well, so I can show you how to do looping over a dictionary. And so with these examples, you'll see how I hold data, especially in a data structure, and we'll take that knowledge to the next class, and you'll see and learn about these data structures in more detail. Okay, with that, we'll start with the while loop. And with the while loop, it's really easy. I'm going to have some kind of condition. So let's create a variable first, just some counting variable. We'll say I is equal to 0. Then I'll say while. We'll say I is less than, I don't know, we'll say 10, my colon, and then I hit enter. Now I've started my while block of code. So here's the syntax. I use the keyword, the reserved keyword called while. Then I put some Boolean expression. In this case, I'm using the conditional operator of less than. And then I'm going to start writing my code. First thing I'm going to do is I'm going to increment I. I'm going to say I is equal to I plus 1. And what that's going to do is now instead of I being 0, the value of I is going to be 1. So now I can print out the value of I. And we'll go ahead and run this code, and you'll see that, hey, I get 10 statements. Let's do a flashback and talk about modulus operators. Remember, modulus gives us the remainder. So I can use the modulus operator. I only want to print out if it's divisible by, we'll do even numbers. If it's divisible by 2, I'd like it to print out I. Let's add some condition statement here. And if you think you can do it, go ahead and pause the video and see if you can write that code yourself. And if you can't, I will show you as an example, and I'd like you to try to type it out yourself as well. Okay, so welcome back. If you got the example, great. If you struggled with it, no big deal. We're going to go over it as an example right now. First thing we're going to do is we're going to do a condition statement. So I'm going to use my if keyword. Now I'm going to use the modulus operator. I'm going to say I modulus, we'll say 2 to be even. If that's the case, I want to print out I. Let's go ahead and see how that looks. There we go. Actually, I did the odd numbers. Let's do this addition after our print. There we go. So now we should get the even. Oh, no, I still get the odd numbers. Plus 2. Oh, we got to say double equals 0 just to make it cleaner. There we go. So 0, 2, 4, 6, and 8. Those are the even numbers from going from 0 to 10. But remember, we don't include 10 because we have less than. So it's actually going from 0 to 9. And all the even numbers are 0, 2, 4, 6, 8. So that's bringing back the modulus operator. Now another thing we could do, instead of using the modulus operator, I could do check for equality. I could say I double equals, pick a number, we'll say 5. Then I will print out I, and only print out I if it is equal to 5. And there we go, we get just that one statement. So if can be embedded in our loops just like anywhere else. It can be its own block of code. It can also be a block of code inside of a while loop. We'll add the word else with while statements. Just like I can have an if statement, I can also have an else statement inside, or actually outside of, it can be paired with a while. So like, you know how I can pair if statements with else statements? I can also pair while statements with else statements as well. You can say something like I is greater than 10, or greater than or equal to 10 now. And what happens is, if this while statement completes without having a break, and we'll learn about the word break here in a minute. Where did I talk about that yet? Break. If I don't break out of the while loop, then the else will run. If I do break out, let's do a break statement here. You'll notice that this else statement does not print. Because what happens is, this while and else are paired together. This break says, hey, I got to break out of this while loop. Where does this while loop end? Well, it doesn't end until after this else statement. So the next line of code over here, this is the next line of code that is outside of our while loop. Our while loop. Now, if I don't break, once this while loop is done, it goes ahead and executes my else statement. Right? So this is really useful if I have some section of code. Let's give an example of using a list. So let's use this as a for statement instead of a while statement. We're going to say for, we'll say I in my items. And let's create items here. And let's give it square brackets, and we'll say, oops, Control Z, apple, pear, or we'll do singular pear, orange, and grapes. Okay, so I'm going to iterate over each item in my list. So this is going to go through. What I want to know now is if melon is in my list. And if it is, I'm going to go ahead and break out. And I don't need to do this iteration now because our list is incrementing I automatically using this for statement. All right, so let me explain this code and kind of walk through it. We have items equals a square bracket, and it's a list of 4 different items. That means we're going to loop through each item, and I'm going to check to see if that item is melon. If it is, I'm going to go ahead and break, which will immediately take me to outside of our for loop and print this line of code. If I don't find melon in my list after I've gone through all 4 items, the next line of code will print no melon in our list. And because there is no melon in our list, we printed out no melon in our list. Let's go ahead and add melon. And now when I run it, you'll see it does not print this because it hits this break statement when it gets to the melon item. This break statement jumps outside of the for loop down here at this print statement. Okay, so that's explaining what break does. Break jumps us from whatever line of code it is outside of whatever containing loop contains the break statement, and that's why we get to here. There's another word called continue. Let's put melon over here in the middle. Just so we can see how that works. And instead of breaking, let's go ahead and continue. And what I want to do now is I'm going to go ahead and print the different items. So I'm going to go ahead and print I. So what's going to happen is I got my list of items. I'm going to run it in a for loop. The first item through the for loop is going to be apple. So it's going to hit this condition statement, the keyword if, our Boolean expression I double equals melon, and then our colon. This is our condition statement. And if it's true, then I'm going to get continue. If it's false, apple is not melon, it's going to go ahead and print it out to the screen. Then it's going to go back up to my for loop and get the next item in our list, which would be pear. Then it'll check, is pear equal to melon? No. Print it out, go back through the list. Is melon equal to melon? Yes. Continue. What that's going to do is instead of running anything else in the block of code below it, it brings it straight back to the top of our for loop and runs the next item. So what I expect to see here is printed as apple, pear, orange, and grapes. And then it'll print outside of no melon in our list, which, let's get rid of this else statement. That's an artifact. I don't want that anymore. And then we'll go ahead and go outside of our list. There we go. So what continue does is skips any item that we have on our list that we're comparing against. So continue just reshoots the code straight back up to that for loop. Okay. Now I forgot to give you an example of an infinite loop. Infinite loops run forever. So if I did that as an example, I could just say while true, hit our colon, just like we had there, and let's just print never ending. If I run this code, this is going to keep printing out never ending to my computer until I run out of memory. Or I stop the kernel from executing the code. So you watch this, we'll just kind of see how it just goes, and it kind of frees up my whole computer and just starting writing code and just keeps going on and on and on and never stops until I hit the stop button here. I tell, hey, I don't want you to run anymore, and stop it. Now I gotta restart my kernel and clear all the output, or restart kernel and clear all outputs. So that's an example of an infinite loop, and if you're not careful, you can cause your computer to crash. Now, luckily I stopped it before it crashed, but that's an example of an infinite loop. Now, you can create infinite loops and actually have them stop after some condition, because we can add condition statements in here. We can say if, and we'll create some variable outside of this thing. We'll say counter equals 0. And then every time through our loop, we're going to increment counter. Counter equals counter plus 1. And what I'm doing here is I've got a variable counter that I'm assigning. Right now it's 0. I'm assigning 0 plus 1. And I'm overwriting the previous value of what was in counter. So now counter owns the value of 1. The next time through the loop, it's going to own the value of 1 plus 1. And now counter owns the value of 2. And every time through the loop, it's going to keep getting incremented. Now, because this is such a common way that we're going to use in loops is this counter, Python has a special variable called plus equals. And what I can do the exact same line of code I just had in a little bit shorter syntax. So counter plus equals 1 is equivalent to counter equals counter plus 1. It's just a shorthand way of saying the exact same thing. So you might see that in your code. I just wanted to expose you to it. You certainly don't have to do it. You can have it the way I had it, but this is just another thing you might see if you look at somebody else's code. So now I can say if counter double equals 10, we'll go ahead and break. Never ending until 10. And we'll go ahead and run that, and you'll see that it prints it out 10 times, because as soon as counter hit 10, it breaks out of that infinite loop. If I removed this and put the word pass, remember pass is a line of code that says, hey, do absolutely nothing, but just know that I intend to do something here. I'm going to recreate that never-ending loop. So I definitely need to have a way to break out of a never-ending loop using a break statement. But go ahead and play around, see if you can create infinite loops and figure out how to break out of them. You can break out of them in clever ways. So that's infinite loops, loops with control statements. We did break, we saw continue. We've seen for loops right here as in our example. And I even did a for loop. Did I do a for loop with an else state block? Let's try that. Else, colon, and we'll say print. Not in list. Instead of continue now, I do have to do a break statement, because otherwise the break statement is what allows us to not run an else statement. Otherwise, it always is going to run, right? If I break out, then I do not run my else statement. If I just hit the continue, it actually runs the else statement. So the only way we don't run an else statement with a loop is if we don't break out. As soon as you hit the word break, it ignores the else statement and goes to the next line of code. So I'll leave that so it makes sense in the example I leave. All right, so we've seen the syntax for loops. It's two keywords. It's the word for to start the loop, and then we use in, and then we give it some list of items. It could be a string, It could be a list like we have here. It could also be a dictionary. So let me explain what a dictionary is. Well, I don't really need to explain it. What exactly is a dictionary, right? It's a thing that you can look up words. I know a word and I have a definition. So in data structures, and we'll see this more on module or on day 3 class, but we'll call this my dictionary is going to start with a curly bracket and end with a curly bracket. That's how we distinguish a dictionary. And we're going to put two things in here. We're going to put a key, so we'll call this a key, colon, the value. And I can put multiples of these in here. I could have, say, like, hey, name, and my name is going to be Jonathan. I can have age, and my age is going to be 42. And I can keep going on by comma separating our items in our dictionary. The first item is what we call our key, and the second item after the colon is the value. So here I have 3 items. I have one called key with its value, then I have an item called name with the name Jonathan, and then I have a third item called age with the value of 42. If I iterate over a dictionary, let's copy this code because I don't want to, if I give you all this notebook, I want you to be able to run these examples as well. If I overwrite them, it makes it a little harder for that. So let's get rid of our items, and we'll stick with our dictionary here. Instead of items, I'm going to iterate over my dictionary, and I'm going to call this my key. So if I put a dictionary as my item that I'm going to iterate over, item by item, it's going to give me back the key. So if you see, the key in this case, for the first one is the word key, the second one is the word name, and the third is the word age. Let's get rid of this noise as well. So we just very focused on what we're looking at here. All right, so I have key, name, and age. Now if I want to get access to the value, I can reference it out of the dictionary. I can say my dictionary, giving it the key in square brackets, and what that does is it's going to access the dictionary by the key and give me the definition, or in Python terms, the value. So now I'm going to, instead of iterating over my keys, I'm going to iterate over the values. So you'll see value, Jonathan, and 42. That's the right-hand side of the colon. And this is a very, very convenient way to handle data from a database, right? If I grab a user's information, I might have their name, address, phone number, I don't know, social security number, credit card number, all that information has a key and a value, right? So dictionaries is a convenient way to manage data from a database. And if I want to iterate over them, I can iterate over the dictionary by just giving it the dictionary name. If I do that, I get the keys out of the dictionary. If I want to get both the key and value, there's a way to do that too, which is kind of fun. So dictionary has items. Oh, I forgot to, sorry, now I can reference, we'll say key plus a space plus the value. And let's go ahead and, oh, I can't do that. I got to make this a string if I want to do that. There we go. So I have the key is value, the name, its value is Jonathan, and the age is 42. But I made them all strings just because I wanted to do simple addition here, right? So that's why I made 42 an age. All right, so what I want you to take away from this is that dictionaries are a really convenient way to hold information that has some kind of lookup field and the value that's supposed to be held in that field, right? We've seen while loops and made them infinite. We've looked at for loops and going item by item. Let's get rid of our dictionary for that noise there. We'll go item by item through our list, and if I hit the break keyword it ignores the else below it. All right, so that's a lot to take in. Hopefully you found this iterating over loops and using for and while loops beneficial. You can start to see how we're building our foundation of Python knowledge, and we're going to start to really be able to have some utility in what we're able to do with our control statements, with being able to loop. And then once we learn data structures next, we can learn how to hold the data. And as we mature on, I can hold the data. Now I can isolate and modify my code to be more precise and make functions and modules. And once I start to do that, then I'm going to go into dealing with the operating system. So you can start to see how we're building our foundation of knowledge to really make Python useful for us. All right, with that, go ahead and take a break. And next section will be using break and continue statements in loops, which we've already kind of seen. So next class should actually be pretty short.